Welcome to this session. My name is Dimitrios and I'm a mentor at Untitled. Today I'm going to speak about the microservices and about the message passing. So this is for the Cloud Native Nanodegree. I'm going to share right now my presentation. So again, this is message passing of the microservices. My name is Dimitrios. This is for the Cloud Native Nanodegree. So this presentation has two main parts. The first part is about the microservices, why we are using them, how we are using them, how we can make our code to use them. And the second part is about the application programming interfaces, about the specific application programming interfaces which the microservices are using in order to communicate with the outer world, in order with the clients. So, what are these? Which are these application programming interfaces, these APIs, and of course, at the end there is a demo around them in order to explore them. Let's go to the first slide. So right now, how the microservices are communicating with each other, and also with the clients. We got here this example, which is about the direct HTTP communication. So we got the HTTP protocol, and we got here this mobile app, which is using the JSON format in order to send a request. And we got here this web app, which is an Angular.js web app, with again with the JSON formed request communicate with this application, with our application, with the cloud application, and with the API gateway. So this gateway takes the requests and forwards some data, add data with HTTP again request to the next microservice. So the next microservice is the shopping basket, which takes the item. And after that, there are more microservices, which is in this order, and they are communicating with HTTP request. So there is a microservice here, product catalog, which can make this product look up. It can be called with this product lookup request. And at next, there is a microservice pricing, which can take the request for the price lookup. So as you can see here, we have one request. After that, there is a second one communication, and at the end there are more two communications with 3-time communication. So 1, 2, 3 is the time of the communication, and it's not very efficient. So this is an example of the communication inside the application with HTTP requests, which are very common, but this is not the most efficient way in order to launch an application and to have good response time, for example. So let's go to the next slide. Of course, the solution is to have more microservices to work in parallel. So if the microservices are working in parallel, the program is more efficient and you got faster times. So here you are trying to make one big code, load of code to a lot of piece of code. So you are trying to separate the modules, to decouple the modules of the code in order to make them microservices. So you got at the beginning the as-is situation. You got here, as you can see, this big order and delivery management service, which is inside the FTGO monolith application. And the clients are sending the request. So this is the order management client. And this is delivery management client. So they're sending the requests about order management and delivery management. And these requests are served from the big monolith FTGO application, and they are sending further the data to the FTGO database. Okay. So this is a monolithic application which has its problems with response times and so on. And this has to be in the form of microservices. So this is the as is today. So the next phase is to be. So all the comments are struggling with this question. How you can go from the monolith to the microservices, and how we refactor the code from monolith to microservices. So you have to do like that in order to the situation. So you got here again the two clients with the different requests, and they are communicated right now with an API gateway. An API. So this API sends further the data to the two microservices in the same time. So you got here the old monolithic application, which is now a bit reshaped, which has only the order management. So the other module is erased, and you just keep the name of the FTGO monolith and has the order management, and this communicates with the FTGO database. So you have also the old database. And after that, if this can search, of course, the order management client. The delivery management client, the delivery management client almost sends the same, sends the same request again to the API gateway, but this time it communicates with another piece of code, with a separate piece of code, which is a delivery service. And now this is a microservice. Maybe it's not a micro, it's a big service, but we call it a microservice. Right now, it's a delivery service which has the code which can serve this request for the delivery management. So this takes the request and sends the data, to take some data or so on to the delivery database, which is a specific database for the delivery. So you keep the old application, you erase you erase some modules that can be erased, and you decouple the application to two new services. And you put this module, and you're trying to make the in a consistent way to the delivery service, and to make the service is going to make the delivery management. So there are two microservices here which are communicated as one application through this API gateway, and these two databases which has more specific data and can be retrieved in much better time, and they can have the whole application can have much better time response and so on. And these two microservices have an integration glue. So this is the main thing to do. So you have to separate these two and decouple these two services, the code in two services, but you have also to integrate each other because it is in a frame of one application. So this is how you can go to refactor the code from monolith to microservices, and as is from as is to D, like that. This is not a very easy way, easy path, but it's a big struggle, and this is how it's gonna be if you want to go to the microservices exploration. So why we are doing that? We are doing that because microservices are much efficient, make our application much efficient, and there are a lot of factors that are doing that. So as I said before, the services have are independent, are decoupled, and have independent life cycles. So if you want to update or maintain one service, the rest of the code is not going to be affected. So you can, even if you have a problem with a piece of code, so you have a specific service that functions, and you have to change this specific service, and the rest of the program, the rest of the service are not going to be affected. The second one is the service can be built with either set of technologies. This is very important because you can have a lot of technologies and they're not going to conflict, a lot of packages and a lot of editions, for example, and you're not going to have conflicts between them. So the older code, you can maintain the older code in a much easier way inside the microservice, and this is going to not affect the newer code that is implemented in other services. Of course, there is a long-standing autonomous teams, so you can distribute your team, not only your code, but also your team, in order to have more specific piece of code. And these are more specialized to this code, and they are more responsible for not for the whole application if it is much bigger than the usual. So at next step, independent services increase the speed of experimentation. Of course, you can test as long as you want with microservices, and you can make the refactoring even much better, and you can refactor again. The next one is that ecosystem enables innovation through composing services. Of course, different technologies can have a better result at the end, and of course, different technologies can be combined here with the microservices, different packages, different editions, different technologies at all. So you can see that code Python with code JavaScript can communicate and so on, can work together in a very good manner. Building small independent services lowers the developer's cognitive load. Of course, this is a bit subjective, but I would say that it's much easier to maintain and manage code that is decoupled, and the microservices are much easier to maintain and to program, of course, not the whole big applications. And at the end, ecosystem enables graph and scale of operation. Of course, at the end, you get even bigger applications and a more efficient application, and this is illustrated in the whole company's results with growth and, of course, the scaling of the company, of the application of the company at the end, product at the end. So these are the microservices, how we can separate them, why we use them, and so on, but how they are communicated, how they are communicating. This is the main, let's go a bit deeper. This is the main question. So we got these APIs, which are make the whole the magic thing behind the microservices and behind the application. So we got the REST API and the gRPC API. So the REST API is the most prevalent API, is the most famous API. It's a representation, stateful representation, which you got here the REST, and you send here a request and you take a response. So this is it's I have also showed a RESTful API in the previous session. This is a kind of communication which you can communicate with a third party. And the second one is this is the unary way to communicate with the APIs. And the second is the gRPC. So with the gRPC, you can go a bit more. So with the gRPC, you have a remote procedures calls. The gRPC means Google remote procedures call, which you can set and get a send request and get a response. And but after that, you can you have the help of the buffers, which is a Protobuf technology, a Protobuf code, and you can send whole streams of messages. So you got here this client streaming, so you can the client can send a lot of code, stream of messages, and the server can take them and send back a response. Of course, you can also have a server streaming with gRPC technology, and this buffer can take, you can send the stream too. So the client send a message, a request, a message request, and it takes a stream of as a response stream of data. And at the end, with the gRPC, also the bidirectional streaming is possible. So the client sends the stream, and the server sends back a stream too. So we got the new way of communication with the APIs, which is the streamings, and this has more advantages than the old REST. So you can do all of them with the gRPC. With the REST, you can do only the unary way of communication. So the gRPC is much faster than the REST in this way, and this is the new way to have for the microservice to communicate with the clients. So at the end, what is this buffers? What is this? The buffers is the Protobuf buffers, which the data is in the shape of message. So we got here this message objects, which let's say we have here this message object, which is an order message. And these are the properties, the fields. As you can see here, you've got two strings, for example, an integer of 32 bits, and of course at the end, the float. A float field. So these are the fields. These are the properties of this object, and you send this message which has inside it this values. And how do these methods are sending and get are be set and get send and get? This is with the Protobuf service. So the Protobuf service here we have the service object. In this time the order service. So you send, you have here inside the service the function that is going to be called. So it's going to be called with the RPC manner, which is an RPC function, which is an RPC function, and it's going to be returned with a RPC call. Remote procedure call is going to be made. So you send this create function, which is RPC module sends the order message and returns back the order message again. Okay, so these two are the most basic things around the Protobuf. So while the message that it has the data and the services that are through that are communicated the microservices and they are sending and getting the messages. Okay, so my references are this: microservices service-to-service communication from Vector. The second one is the microservices.io, which is a very nice blog refactoring a monolith to microservices. And the third one references how to break a monolith into microservices. This is the blog of Martin Fowler. And the last one is the gRPC versus REST, comparing APIs, architectural styles. So this is the imaginarycloud.com, which is a very nice blog too. So at last, I'm going to show you a demo with these two types of APIs. I'm going to share my the code right here. So here you got this RESTful service. So as you can see here, this is the project file. You got here this three Python. This is a Python project. You got here this Python files. So the first Python file is the app.py. This file is the role of the server. So we got here the server, and we're gonna set up the server in order to get the request and of course to send the request. So this is a Flask application. So I'm gonna import from the Flask and the JSON define in order to make the data in a JSON form and the request in order to make the request and with the functions of this package. So there's also a services file which has two main functions: retrieve orders and create order. So we've got here this app Flask with this Flask app which is defined here. After that, this is part that is I'm gonna not call it. You got here this app route. So you set here the route that through this route the application is gonna communicate with the outer world. So the route is API /order/computers, and this is the route that is gonna have the data in order to communicate. It takes the request. The method that this route is communicated is the get and the post. So you can get, you can have a request get and also submit a request post. And these are the function that has inside it and is going to be called with these requests, types of requests. So you have the def computer, which is the main function, and if it is the get here, it goes here, it returns it calls the retrieve orders function from the service.py, and at the end it makes it in a JSON form. Otherwise, if it is a post method, the request is the method of the request is a post. So you got the request body here, which is a JSON, and you put this body, this JSON, you put it in as an argument to the create order inside the services, and you make it in a JSON form, and you return back this. Otherwise, there is an unsupported HTTP request exception message. So at the end, you run here the function. Let's see the next with the services, which here are the functions. So the functions here from the enums here, which is another module. Here you import the status. So you have the first function create orders. It takes the order data as an argument and it takes the same one. So this is a dummy function. The next function is retrieve orders, which you can which is the result of the GET request. So the return is that you have these hard-coded values, and ID is 1, status is the queued num value, which I'm going to show in the next module, created at, created by, and so on. So you got here two JSON, one response with two JSON parts, let's say, and at the end, the enums. Python is here the class status, which for this specific field, you got this validated values, so you cannot have any other value. Queued, processing, completed, and failed. This is the validated values of the status. So I'm gonna debug this code in order to know how it runs. So right now, connect to PyDev debugger. Yes, the Flask app. So here is the running on localhost and the port that is the application export is the 5000. This is the server for our application, and I'm gonna make some requests. So to make the request, the Postman application is helping me. And now, so this is the client. Make things clear, and I'm gonna send a GET request, as you can see here, to this route, as it is a route of our server. So localhost 5000 port, and after that is the route API orders computers. So I'm gonna send a GET. GET does not need any arguments. Okay, so right now it's sending. It has sending the test. Let's go back to our. So right now here has gotten the request. As you can see here, the request has come from the app here, app route. The dev computers is called, as you can see here. The request is a GET, as you can see here. And after that, it's gonna call this function, and it's gonna JSONify it. It's gonna make it a JSON. The function is called, has been called. This is the retrieve orders, which returns this whole JSON message. As you can see here, line by line, this is inside the framework of the Flask. I'm going, okay, it is in the next. So this is the status that is taken, the next and the next. This is the second JSON object, again, inside the framework. And these are the next values. So now it's the return, and the value is returned, okay? And it's gonna be JSONified and returned back to the client. So this is inside again the init.py is inside again the framework. Again inside the framework. This is again inside the framework. Okay. Request. And the request is sent back. Let's see the response has sent back. So it is 200. Okay. And as you can see here, this is the response, the two objects, JSON objects that are formulated inside the function. Go back again to the JSON. So as you can see here, this is done through this piece of code. We'll clean that a bit. So let's see right now what's going on with the post request. So the postman is gonna make also the post request. As you can see here, this is again the route, the port. On we got here the body. So the body is gonna send this JSON, which is the third object, JSON object, let's say, status queued and so on. I'm gonna push send. This is sending the again the back the request. Okay. Okay. So this is taken right now. Let's see. So right now this is create order. So it goes here to create the order. This is a post request. So we get this request in order to post the data. This is a create order. So we got here the app, which has been, it's running always. And the request right now is the post request. And the post request has here return this, call this create order with this request body that we have gone from the postman. And this create order has been called. Here, the create order has been called and it returns this order data. As you can see here, this is the data that is posted, ID3, status queued, created, and so on. And this is going to be returned as it has came. So let's go further. So as you can see here, the request body is here. This is request body here with the JSON form, and is the function has been called, and after that we JSON define with return back. The function gets back. So let's go inside it. This is the init. Okay. This is again the Flask app. So this is framework code that has been called, and at the end, the app has been sent the response. Let's go back to the Postman API. As you can see here, this is created. Okay, created by and so on. So this is the response. Okay, let's go back. So this is the REST API. In another session, I have done a client app with Android with Java. So I'm sending you there the data, some data, and I'm getting back another response. So the next thing to show is the gRPC. So the gRPC is another here. So we got here the main, which is the server. We got here import time from concurrent import features, import gRPC, which is a module for the gRPC, import ordered PB2, PB2 gRPC, import ordered PB2 gRPC, which are the Protobuf modules. And here you got the order servicer. So here you got this function that makes the get request. For example, request context that are going to be set. First order here is the when you are trying to get some data, you get this coded data as before. And at the end, the result is here, the order message list, which is set in the another file in the order proto. The result here, and after that you have this sends back a list, and the list is going to be extended with the first order and the second order in the frame of the order, and you're going to be returned. So you can hear these two messages. The list is going to be created, and the list is going to be populated with these two messages with the extend, and then you understand the result. The second one, the second function is the create. So if it is, let's say, a post, like a post request, so you get here the request and the context. The received message is printed, and after that, the request value is this. So again, it is this JSON object is going to be populated with the request values. Now that's going to be printed. It's going to be returned from this function. This keywords and the values are going to be returned. At the end, the server here has the initialization of the gRPC. This files has the initialization of the gRPC server. Here, as you can see, this is a gRPC server which is going to be have the two worker instances, and this is going to be configured through the thread pool executor inside the features. And after that, the order servicer and the function is going to be implemented inside the server. So if you call on the server, you're going to call this order servicer function. And this can be done through this function from the order PB2 gRPC module. This is a result of the Protobuf functionality, the Protobuf function. But at the end, you print here a message and you send the insecure port. So this is the new port that is going to be opened to communicate with the application, and the server starts. So here, try the time sleep and so on for the server in order to keep the server alive. And the next one is the order proto. So this is the protobuf code that I have shown before. This is the message. You have here the fields, the null field, and more fields than that. And at the end, you got an empty message. If you got an empty message, and here it is the list that is going to be created. So here in the list, you got this repeated order message. You have a lot of order messages here with this repeated keyword. And you have multiple messages, and you make a list out of them. And at the end, order service has this RPC functions, which is going to be called with RPC way. So this create takes the order messages and returns order messages, and the get takes the empty and it takes the order message list, which is the hard-coded values that are inside in the previous function. At the end, you got a getter, which is gonna make the request. It plays the roles of the client in order to make the request to get some values. So you got here again the same modules, and you print a message. You send again the same channel in order to communicate with the API. And this channel is gonna be in the function, in the stub function. So you're gonna stub this function through this through the calls of this channel, and at the end you set this with this tab you set this function get. So you get with this you get in this this function is gonna if you call this getter you get something with the function order pb2.empty. So you get the it's called the function empty is called through this order pb2 file, and it's gonna be stubbed inside this channel, which is the localhost dot double dot 5005, the port, the open port, and the response is going to be printed at the end. Another client, the other module that has the role of the client is the writer, so this is going to write something inside the application, let's say. So here it prints again some things. Again, you set the channel, and the channel here is going to be stubbed. The function is going to be stubbed inside this channel with the stub, and at this time the order message is this hard-coded again values, which is gonna be set inside the order. So let's go to run this code. So we stop this server. As you can see here, these are the two prior requests. This is the GET request, this is the POST request. Both of them were successful, and we are running the gRPC server right now, which is the main. Let's try it again. Okay, we got here the server, which runs. Let's see. This is the time sleep, and now the server is running. And after that, we're gonna run the getter, this client. As you can see here, the channel is set. And here are the stub is the get is gonna be called with within the stub. And as you can see here, the getter has called the get method. This is the request that is going to be it's going to get this empty response, and after that, this is the request with the empty argument, let's say, and after that, these are formulated, and this is the second order, let's say, and this is the message list, and this the message list is going to be extended with the two main headers, as you can see. This is the ID 2222, and the second JSON object is the 3333. Okay, so you can see here, the server has gotten the value, and it's going to return it. This is framework response, and as you can see here, the response is taken, and we're going to be printed. So as you can see here, these are printed, sending sample payload, and these are what we get as a response, and it's printed inside the terminal, inside the function, inside the application. Okay, as you can see here, this is the how we send a request in order to get some values from the gRPC server. Let's see how do we write data. So we are using the writer. As you can see here, the writer has been called. Okay. So as you can see here from in the properties in these values, the channel is that. The order is that again. So as you can see here, it has run, and you can see here this values. And after that, the stub is that object, sub object, and there are some special variables. So the response is gonna be sent. The request is gonna be sent. So it is it calls the create function in the server, and the response is gonna be the result of this call. Let's go next. This is the framework. So the create has been called inside the server. This is the main.py. The request is that, as you can see, is formulated. It's printed. It's gonna be printed. Actually, the function is running, and at the end it returns this request value out of this. Okay, with the keys and the values, of course. So again, this is the framework. Let's go. Okay. So right now, as you can see, the serving is running, receive the message ID. This is the ID that has writer. This is the object that has been sent, and it's gonna be returned back. It's gonna be printed. It's sent to the server. It's gonna be printed inside the console. So with these two words, this is the main functionality of the REST and the gRPC. The code is gonna be the GitHub code. The GitHub repository with this code is gonna be inside the description of the video. I would like to go back to my presentation. So if you got questions, I'm open for discussions. You can write a comment, and I'm gonna come back to answer. Thank you very much for watching. See you at the next session.